Good morning. Polymer Chemistry Unit 1. It is a LT paper. Polymers used for various applications in industries and defense sector and sports also. So it is day to life. We cannot avoid these polymers in day to life. It is without polymers we cannot live in this world because it is everywhere in used these polymers in some day to life. Yeah, polymer is a macromolecule. Macromolecules means a big molecule formed by small molecules. It is called monomers. So polymer word is derived from Greek. It is poly means many, mer means small parts. So small parts are combined together forms a big molecule. It is called polymer. Polymers molecular weight is compared to other ordinary chemicals. It's very high. Sometimes thousands to lakhs and lakhs. Its molecular weight. Uh, the first synthetic organic polymer was synthesized from poly petrochemical. It is a polyvinyl chloride in 1838 accidentally. In 1839, polystyrene was discovered. Some examples for the polymers, monomers and polymers are ethylene. Ethylene molecule is a monomer for the synthesis of polyethylene. Under heat and pressure produces polyethylene molecule. Polypropylene is produced from propylene molecule. Propylene is a monomer. Acrylonitrile is the monomer for production of polyacrylonitrile. Methyl is a monomer used to produce polymethyl acrylate. It is called PMMA. Vinyl chloride already we know used in various applications like electrical insulating material and used for water pipeline. So it is a vinyl chloride is a monomer. Vinyl chloride is produced from ethylene with ethylene molecule with reaction with chlorine and produces vinyl chloride, and finally we get polyvinyl chloride undergo polymerization reaction. And another monomer is styrene. It undergoes polymerization, produces polystyrene molecule. It is used for various applications. Um, Tetrafluoroethylene is Teflon. It is used for non-corrosive material. So it derived from polymer is polytetrafluoroethylene and used for industries. Classification of polymers based on the origin of source is classified into three types. One is natural polymer, next one is semi-synthetic polymer, next one is synthetic polymer. Based on structure, structure based three types. One is linear polymers, branched chain polymers, cross-linked polymers. Third one is based on molecular forces. So this molecular forces also some different kind of properties gives the polymers to. So it is elastomers, fibers, thermoplastics and thermostatic plastics. Another classification based on the mode of polymerization. Then it is classified into two types. One is addition polymerization, another one is condensation polymerization. So there are four classification. We will get different kind of polymers based on structure, then source, and then based on the molecular forces and the polymerization mode of polymerization. So based on the origin of the source, it is divided into three types: natural polymer, synthetic polymer, semi-synthetic polymer. Natural polymers are which are isolated from natural sources or natural materials. The examples for these are cotton, silk, wool, and rubber. Then synthetic polymers, which are obtained from petrochemicals, it's their molecular weight polymers, monomers are used to synthesize the higher molecular weight polymer. Polyethylene and nylon, toluene are the examples for the synthetic polymers. Semi-synthetic polymers, these are the polymers are mostly derived from naturally occurring sources by chemical modification. Example, rayon. based on structure copolymerization. The composition of polymers is a sequence of repeating monomer units that are covalently bonded together. So the molecules are covalent together, so the very strong polymers. The functional groups on the repeating units provides the relative reactive sites for corresponding reaction. The repeating units of polymers have variety of possible structures. So they are having homopolymers and different structures like polyvinyl chloride example for this copolymerization. When the different copolymer is made up of more monomer species, two more monomer species. Many commercially important polymer or copolymers. Example include polyethylene, polyvinyl acetate, ethylene acetate (PEA), nitrile rubber, and acryl nitrile, and butadiene styrene (ABS). A polymer chain that forms a polymerization reaction consists of two or more different repeating units. In step growth react polymerization, the polymers generally form an alternating copolymer. A copolymer consists of two or more chain of repeating units bonded together to form a longer polymer chain. Example: anion polymerization of styrene products the following the dianion. This kind of polymeric dianion is called living polymer. After a living polymer reacts with the monomer available in the reaction solution, can be added another monomer. All the above examples are linear polymers. Some of the polymers are contain additional covalent links to repeat units of various locations on the backbone. Such polymers are called branched polymers. Linear or branched can be connected with some additional covalent bonds. These polymers are called cross-linked polymers. Network or class-linked polymers. In this, monomeric units are linked together to constitute three-dimensional network. The links involved are cross links. They are hard, rigid, and brittle due to their network structure. Bakelite, melamine, polymer resins, vulcanized rubber are the examples for these polymers. Cross-linked polymers consist of small polymer chains that are bonded together. Each chain is bonded to multiple chains. Generally, the reaction proceeds first synthesis the pre-polymers. The pre-polymers then undergo the reaction that links them together. So the cross-linked polymers are prepared from the pre-polymers. The pre-polymers undergo reaction that links together a polymer. Classification based on monomer. Intermolecular forces are forces that hold atoms together within a molecule. In polymers, strong covalent bonds joined atoms to each other. In individual polymer molecules, intermolecular forces attract polymer molecules towards each other. First one is elastomers. Elastomers are rubber-like solid polymers. They are that are elastic in nature. When they say elastic, we basically means that the polymers can easily stretched by applying a little force. When we are applying the little force, then the polymers are stretched. The most common example for this can be rubber bands, and applying little stress elongates the band. The polymer chains are held by weakest intermolecular forces, hence allowing the polymers to be stretched. But as you notice that removing the stretch also results the rubber band taking up the original form. This happens as you introduce crosslinks between the polymer chains with the help in retracting its original position and taking its original form. Our car tires are made up of vulcanized rubber. This when we introduce sulfur to cross bond the polymer chains, and it can retain its original position when applying the heat. Thermoplastics, thermosetting plastics fibers are other three based on classification based on molecular forces. Thermoplastics are long chain polymers which interact intermolecular forces under force hold to the chain polymer chains. These polymers are heated and softened and hardened when they are allowed to cool and forming hard mass. They do not contain any cross-link and can easily shaped by heating using molds. A common example is polystyrene and PVC. Thermosetting plastics uh, are polymers which are semi-fluids in nature that are low molecular masses. When heated, they started cross-linking between polymer chains, hence becoming hard invisible. They form three-dimensional structure on the application of heat. This reaction is irreversible structure. The most common example is thermostatic is bakelite, which is making electrical insulation. Types of polymerization reaction. Polymers are synthetic two types. One is addition polymerization, another one is condensation polymerization. And addition polymerization, the polymers are formed by addition of monomers having multiple bonds. They undergoes periodical mechanism. There is heat and pressure and temperature is used for the production of these addition polymers. The periodical used for this is benzyl peroxide. For example, ethylene molecule we are using initiator and polyethylene is produced. Chain initiation step. Benzyl peroxide reacts with this monomer of this ethylene and produces peroxide polyethylene monomer as chain. Then another monomer is used added to the continuously in chain propagation step. Finally, chain is terminated by using two methods. One is dispersion method. Chain growth polymers formed from radicals, cations, anions because of wide variety of monomers lend themselves so readily to form formation of radicals. Most chain growth polymerization reactions proceed via radical intermediates. Some monomers do polymerize with ionic initiators, but that number is far fewer than those that polymerize with the radical initiator. Chain growth polymerization reaction are usually from vinyl polymers. One such vinyl polymer is polystyrene. Polystyrene polymerases undergo radical cationic and anionic initiation. This section examines all three. The radical polymerization styrene uses benzyl peroxide as initiator. As in with the radical reaction 10 minutes you studied radical polymerization, three steps is the initiation, propagation and termination. The first reaction of styrene is more chain initiation step undergoes chromolytic cleavage to form to benzyl peroxide. This benzyl peroxide undergoes chromolytic cleavage and forms to benzyl peroxide. In second step, the benzyl peroxide and combines with the styrene monomer and produces benzyl peroxide and monomer complex. In propagation step, chain begins to grow with the another styrene molecule. When continuously adding this styrene molecule, it produces a chain length, polymeric chain. Then finally chain is terminated by using removing the radical from the polymeric chain. Thank you.